Hi, welcome to grade 9 physics. Before starting our topic, I would like to say something about some certain things about grade 9 physics. If you are asking your seniors what they felt about grade 9 physics, most of them will say like it was a bit difficult, it was confusing in the beginning, we were finding it difficult. Commonly you can hear these kind of comments. What happens to physics when you come to grade 9? When compared to grade 7 and grade 8, then you can learn some concepts and you can write the answers very easily. But grade 9 onwards, the approach towards or the nature in which we are treating physics completely changes. You have to learn a lot of equations, we have to use graphical methods, we have to solve a set of numericals. So you will take a little bit time to adjust to this new form. But gradually you will adjust to that one. Okay, so don't give up yourself in the beginning. Most of them will find it in the beginning a bit difficult, so they will lose their mind. Don't do like that. It takes some time because we are going to a new approach, so you will take some time to adjust to that one. So work hard. And another thing is that you have to, whatever concept in the school or in tuition centers, whatever things you are learning, try to make it thorough that day itself, okay, because these all things are connected. So the previous concepts you need for the to learn a new one, so make sure that one that you are learning in a systematic way. That will help you to make things much easier. So let's begin our class. In grade 9, you have to learn five physics lessons. The first one is motion, second one is forces and laws of motion, third one gravitation, work and energy, the last one sound. The first four lessons are really connected to each other. We need almost whatever concept you are learning in first lesson, you have to use that one in second, third and fourth one. So that is another reason the way the students are finding it difficult, because if you are not, the concept are not clear in the first lesson itself, you have to use in the following lesson. So if it is not clear for you, you will find it difficult. Okay, so make sure that whatever concept you are learning, it is very clear for you. It will help you to solve the numericals fast. If you are getting a new question also, you can do it very fast. Okay, so let's start with motion. This is your first lesson, chapter 8, motion. This is a PDF file I downloaded from online. If the textbooks are not available, you can download it chapter base. And if you want, you can take a printout, or otherwise you can just refer to these portions. Okay. So let's come to the portion motion. The word motion is very familiar for us. We see different types of motion in our daily life. Say for examples, bird is flying, wind, wave motion, moving car, a ball flooring on the a ball rolling on the floor. These are different kind of motion you see in a regular basis. Okay, actually motion, you can see some kind of motion in a very microscopical level. For example, the atoms, electrons are moving around the nucleus, atoms are vibrating inside a substance, and to a very large scale motion you can tell planetary motion, where the planets are moving around the sun. Okay, so different variety of motions we can see around us, and that makes motion so important in physics. Then what is this motion? When you will say that you are in a state of motion, suppose I am asking you, are you in a state of motion? Most of you will say, suppose you are sitting at a place and you are watching this video, you will say, no, we are in a state of rest, we are not moving. But is it true? Like if I'm asking you that question again, some of the students, most of the time I can see some 2 or 3 in a classroom, they will say, no, teacher, we are in a state of motion, we are moving along with the earth. This is true. Is it? We are moving along with the earth. Then why for some person it is at a state of rest, and for some person it's in a, actually both of you are correct. Okay, suppose you are sitting at a place, compared to your surroundings, your position is not changing, so you are in a state of rest. Okay, suppose you are sitting on a chair and you are watching the video, you are looking around, your position is not changing, so it is correct, you are in a state of rest. But if that, so your surroundings is your reference point in that condition. Okay, but suppose a person is telling that, okay, a person who is in a uh, space station is watching you. So we are living on earth, so for him, how he feel, like we are moving along with the earth, so we are in a state of motion with respect to that particular person. With respect to our surroundings, our current surroundings, we are in a state of rest. And for a space station, the person who is watching us from the space station, with respect to him, we are in a state of motion. That means motion is relative. We can find many examples to prove this statement. Motion is relative from your daily life. For I will tell another example. Suppose you are observing a man who is having a pen in his pocket and he is walking. For him, with respect to that particular person, whenever he is looking at his pocket, the pen is there. So the pen is in a state of rest for him. But suppose we are watching him, suppose we are observing the movement of the pen, so the pen is changing its position. Okay, along with the man, the pen is also changing its position. For us, the pen is in a state of motion, so motion is always relative. Okay, for explaining motion, we always need a reference point. Okay, or we need an origin with respect to which point you are going to observe your motion. That is very important. Okay, that statement is there in your textbook. You can see that. To describe the position of an object, I highlighted, you can have a look at this portion. Therefore, to describe the position of an object, we need to specify a reference point called the origin. That is why we are the statement, why there is a statement like that, because you have to explain it, you have to describe motion related to some point, because it is relative. For some person it is at rest, for some person it is in a state of motion. So you have to specify a reference point. Okay, so that is the first thing about motion. Before going to suppose we want to describe motion, we need a set of physical quantities. All the in physics, not only in physics, I think in chemistry also, you can see a set of physical quantities. Okay, what are these physical quantities? Physical quantities are quantities which can be measured. Okay, for example, we can measure our weight, we can measure our height, we can measure our body temperature, but certain other things, like we cannot measure our happiness, sadness, or these kind of emotions. So the a set of quantities which can be measured are called physical quantities. Whenever I am expressing a physical quantity, for example, suppose I am telling height. Okay, 165 centimeter is my height. So you can see a number over here. The numerical value of a physical quantity is called magnitude. What do you mean by magnitude of a physical quantity? Physical quantity, that means you can measure it. So whenever you are measuring it, you have to express it in certain numbers. That particular number is called its magnitude, because this word we have to use in following lessons also. So don't forget, magnitude is the numerical value. Another example, suppose we are telling body temperature 37 degrees Celsius. This 37 is the magnitude. And this one is the unit. Degree Celsius is the unit. Okay. So most of the physical quantity, no, all the physical quantities are having magnitude, and most of them are having magnitude and unit. Okay, so whenever you are expressing a physical quantity, you have to write its magnitude and you have to write the unit. Then, what are the physical quantities we are going to use for describing a motion? We cannot just tell that. Suppose when I am asking you, describe yourself, you can tell your name, where you are staying, these type of things you can tell. The same way, in order to describe a motion, we have to use a set of physical quantities. Distance, speed, how much time it is taking, acceleration, So these are some set of physical quantities we are going to use for describing a motion. Okay, for that one, first we have to learn, or we have to find out what are these things. Okay, what are the uses of these things, how we can express, what is the difference between these physical quantity. So take the first set of physical quantity, which is distance and displacement. Okay, the first set of physical quantity is distance and displacement. Distance and displacement. Distance, most of you know what is distance. Okay, distance is the total path covered by an object, but I think displacement is comparatively a new term for you. Distance we use in our daily life also. Displacement we don't use in our on a regular basis or something. I don't think that we use displacement. Normally we use the word distance. Okay, then what is the difference between distance and displacement? Why we need two different things to describe, the two different terms to describe motion? Distance, as I told, is the total path covered by an object. A best example I can say is, when you are in the school, suppose this is your classroom, and from the classroom you are going to washroom. Okay, so by going towards washroom, most of you will go in a straight path. Suppose this is 30 meters away from your classroom, you will follow a straight path and you will go from classroom to washroom directly. But when you come back, there will be some deviation in the path. You will go from here, sometimes you will peep into others' class, just take it, roam here and there, and you will come in this way. Okay, so look at these things. Actually, you are moving from classroom to washroom, and you are coming from washroom to classroom. The path taken by you is different. Okay, the first path, the way you are going from classroom to washroom is straight path. Okay, that means it is the shortest distance between these 2 points. Okay, so the shortest distance between any 2 points is called displacement. So the journey, your journey from classroom to washroom is displacement. But when you are coming back, your journey from washroom to classroom is an example of distance, not displacement. Okay, because this is not the shortest distance you are taking. So actually, when you are in this journey, in the journey, first journey, the distance and displacement is same. Okay, you covered this much distance, and this is the same time, this is the shortest distance. But in the returning journey, the thing is that this cannot be displacement. Okay, this can be distance because this is the total path covered by you, but this is not the shortest distance. So number 2 is distance, but this one is not displacement. But the number 1 can be distance and displacement. Okay, so the shortest distance between any 2 points is known as displacement. Another example, suppose I have 2 points here, A and B, and I have some path like this. Okay, this is one path, this is another path. So first one, second one, third one. I mean, this one, which is displacement, the first path is the displacement, because this one is the straight path and this one is the shortest distance between the points. But now 1, 2 and 3 all can be distance. Okay, depending upon the path you are selecting, the total path covered by you is distance, while displacement is the shortest distance. Okay, so that's the first difference between distance and displacement. Now let's take an example that is given in your textbook. So this is one example you can see in the textbook. This example, this is our origin. Okay, so this is a straight path because we are dealing with straight line motion here. So he starts from this point, and in the first journey here, he is going to the point A. Okay, so when he is moving from 0 to A, What will be his distance? Distance means the total distance covered. So he is from 0, this is his initial position, this is his final position. So total distance is 60. What about displacement? Displacement also, this is your initial point, this is your final point. What is the shortest distance or the straight distance between these 2 points? Shortest distance, it is 60. So in this case, distance and displacement is the same. While he is traveling from 0 to A, distance and displacement is same. Okay. Now, after reaching A, what he is doing? He is moving back to B. So this is his his first point he reached. Now he is moving back to B. Okay. So this is his initial position. Now after some time, B is its final position. Now what will be the distance? Distance is the total or real path covered by him. What is the real path covered by him? 0 to A. That means 60. Then from 60 to 35. 60 to 35, how much distance? It is 25. Is it? So he has to cover, first he has to move from 60. Okay. He is moving from here to here. So first one 60 plus, now he moved how much distance back? 5, 10, 15, 20, 25. So 85 is his total distance. Okay. His total distance is 85. What about his displacement? Displacement is the straight or the shortest distance between initial point and final point. He started from here, so that is his initial point. What about his final point? Final point is B. Okay, what is the distance between his shortest distance between the initial point and final point? It is 35. Is it clear for you? He started from here, he went to A and he came back to B. Okay. When you are calculating distance, you have to calculate the total distance covered by the object. So he 60, from 60 he came back to 35. So 60 plus 25, that means he covered 85. But displacement doesn't worry about what you did in between. Okay, it is concerned about your initial and final point. If my initial point is 0 and final point is B, what is the shortest between them? It is 35. Okay, so this is, can you calculate for C? Okay, I will calculate for C. It will be 60 plus 35. So it is 95 will be the distance. And what about the displacement? Displacement will be 25. So this is the way you have to calculate distance and displacement. Okay. From this point, you can see that distance and displacement can be equal. If it's a straight line path, distance and displacement can be equal. And from this example, you can see that distance is greater than displacement. Always displacement can be equal, distance and displacement can be equal, but displacement will never become more than distance. Okay. Now take another example. He started from this point, so this is his initial point. He went to A and he came back to the same point. Okay. What about his distance and displacement? What can you tell about the distance and displacement? Okay, that means he started from A, he started from O, he went to A and he came back to O. What is displacement in this case? What is this initial position? His initial position was 0. Final position is 0. Same places. So displacement is equal to 0. But distance OA plus AO. You have to add the total path and you will get the distance. Okay. Now, so we told what is the difference? Differentiate between distance and displacement. Next point is distance can be equal or greater than displacement. That's the next point. Okay. Now let's see what is the unit of distance and displacement. Distance and displacement mostly we will express in terms of meter. You can use kilometer, centimeter, no problem, but we have something called standard internationals. Okay, so mostly the even though we have many units like centimeter, meter, kilometer, miles, but which is our meter is our SI unit. Okay, that is our standard unit. Better you express in terms of meter. Now, can displacement become negative? What about negative displacement? Distance can never be negative. Is it because it is the total path? Wherever you go, we will add up and we will calculate. Let's see using an example. This is my origin. Okay. Then both sides I have marked 10, 20. Now let's see. I started from O, I went to A. Okay. Then I came back to B. This is my question. My journey started from O, I went to A, then I came back to B. What is your distance? What is the distance covered? I started from 0, I went to 20. So O to A 20. Then I came back to O again. So A to O again 20. Then from O I went to B. So what is the distance over here? 10. So what will be it? It will be 50. Okay. Then what about displacement? How I will calculate displacement? Displacement 0 to 20. I went 20. Then after from A, I again came back to 0. That means when I am in 0, my initial and final position is 0. So 20, again I came back. So 20 minus 20. Why I used minus 20? Because this way it is plus 20. So when I came back, it is minus 20. Then by the time I reaches O, from O to A 20, from A to O again 20, but the displacement by the time I reaches to O, the displacement become 0. Okay, from 0 again I am moving to B, but B is on the other side. Okay, so this is my from here I am going to this side. So this side you have to take as minus 10. Again, when you are taking distance, you just want to take the total path. Okay, but when it comes in the case of displacement, you have to consider the direction. Suppose we are first it is moving like this, we will take it as plus 20. But when it comes back, we will take it as minus 20. Okay. That is why when it is moving from 0 to 20, it is 20. When 8 to 0, minus 20. So by the time he reaches 0, 20 minus 20 becomes 0. Now from 0, he is going on the other side. Actually, he was moving, he is supposed to, same like your axis thing, okay, x-axis and y-axis. Now he is moving towards negative x-axis, so we have to take the displacement negative. Okay, so displacement can have this. When you are expressing displacement, you have to take care of the direction. If it is moving in a positive x direction, we will take it as positive. If he is moving in the opposite way, we have to take the magnitude as negative. Okay, so that is the difference between distance and displacement. Distance never become equal to 0. Okay, displacement can be 0, displacement can be a negative number. Distance always positive, it will never become equal to 0. Distance is equal or greater than displacement. Okay, so these are some facts about distance and displacement. I have included some questions at the end for you to check your understanding how much differentiate between distance and displacement. Give us a unit of displacement with the help of an example. Explain how displacement can be negative. Actually, that point is not there in the textbook. It's an additional information. So if you want, you can study that one, how displacement can be negative. Okay, whenever you are expressing the displacement, you have to take care in which direction the object is moving. If the object is moving in a positive x-axis, take it as positive. If it is moving against that particular direction, take it as negative. Okay, another question also I have given. Please try to solve it. If you are finding difficulty, you can ask me how to solve that one. You can comment below the um, video. The next class, what I am going to do is that you can go through the topic if you want, and we have some questions related to that one. So we will start with that one in the next class. Okay, please, any doubt is there, please comment. You want me to explain any point further, I will do that one. Okay, thank you.